Hello children. In the last class we had started the chapter with the matrices chapter, right? And in the chapter we learned the types of matrices with the definitions, and once more I'll tell you the definitions are very important, and especially if the particular terminology is not found you lose the mark. So be particular about the right definitions right from the textbook. Okay, put it exactly in the way it is in the textbook or the way we have done in the last class. And we had learned like the general form of the matrix and how to construct a matrix, and the possible number of matrices if they have given the number of elements, finding out x and y value if they are equal. So this much we had completed in the last class, and now coming to this chapter, I guess I have told you already the weightage. I shall tell you the weightage of this chapter for the PU board examination, and along with that today we are going to learn the addition, multiplication of matrices, the properties under them, and how to find out the unknown values in case if you have x, y, z in the given equation. Now more than this, there is something called as finding out inverse by elementary operations, or there is a property called as every matrix can be written as the sum of a symmetric and a skew symmetric, and for that we are going to learn symmetric, skew symmetric and things. So matrices is a chapter where not only addition, multiplication, the application of that is very important in the day-to-day life, that is in the media based stuff, things like census and stocks and shares. So these are like very vastly used. And coming to your PU board things, this has a large weightage and the very simplest of the chapters. So we'll go to the properties of the matrices today. Now continuing with the addition and subtraction of matrices, we have operations on matrices. Under that we have addition of matrices, difference of the matrices. So let us start with operations on matrices. Now what are the kinds of operations that you describe in mathematics? Addition, multiplication, subtraction and division. So based on that, on matrices we don't have something called as division, but we have the rest of the three. Now coming to addition and subtraction of matrices, directly I'll tell you addition and subtraction of matrices together, I'll tell you, because there is no difference at all between these two operations for us when we do. Suppose I have been given A matrix and B matrix, you want to add them, then just add the corresponding elements A11 to A11 here, and A12 to, let me call this as B11, B12. So A11, B11 you will add, A12, B12 you will add, you will get the 11 and 12 elements of A plus B matrix. Similarly A minus B, you want difference of matrix, we want A minus B, suppose you are going to subtract the corresponding elements in the two matrices as required. They are telling here to A minus B. So coming to addition and subtraction of matrices, the main point what we discussed now was what? Add or subtract the corresponding elements. Okay, and so now this is the only point that I want to tell about the addition and subtraction. Now when we do the problems, that will be quite clear. So we are going to the problems that are visible here. Question number 1, I will directly take A plus B. This is question number 1. A plus B will be equal to root 3 1 minus 1 2 3 0 plus 2 root 5 1 minus 2 3 1 by 2. So let us do A plus B is equal to C, root 3 plus 2. So I shall write root 3 plus 2, 1 plus root 5, 1 plus root 5 minus 1 plus 1 will be 0. So we finished the first row addition. Now second row to second row, 2 minus 2, 0, 3 plus 3 will be 6, 0 plus half is half. And children, in the same problem, if I had to do A minus B, obviously I'll do just subtraction. So what would be A minus B then? Root 3 minus 2, 1 minus root 5 minus 1 would be minus 2, and so on. So there is absolutely no difference between the methods of addition and subtraction of matrices. It's the same thing. So if we want addition, we do addition. If we want subtraction, we do subtraction. There is something called as scalar multiplication. See here in the next problem, let me finish question number 2 also. We have question number 2. Again they are telling us to add a plus b. Here we have taken irrational numbers. They have only whole numbers here. 2, 3, 1, 0 as A matrix plus B matrix is 1, 2, 3, 1, 0, 1. Okay. And now see, to do the corresponding elements, do we have the corresponding elements between the two matrices? Okay, let me call. This is very, very important. So now we are coming to our note point. Addition and subtraction of matrices is possible when, see now here I did a plus b here, and now they have taken the whole numbers, and now can you add up this? See, 2 plus 1, 3 plus 2 I can do. What to do with this 3? I can't retain it as it is, or I cannot assume that there is 0 0 here in the third row. No, third row does not exist at all. I cannot write 0 0 also. So now addition and subtraction is possible in matrices if and only if both are of the same orders and all the elements, corresponding elements are available. See, what is the order of this? This was 2 cross 3, and the order of this matrix also was 2 cross 3. So the answer matrix, the addition matrix what I got also is of the order 2 cross 3. And then here you see a plus b, this is of 2 cross 2 and this is of 2 cross 3. The orders are different, so a plus b is not possible. So here I'll write a plus b is not possible. Is not possible because orders are not same, because orders are different. Okay, addition and subtraction of matrices is possible if and only if they are of, if and only if the matrices are of the, if and only if the matrices are of same orders. Yeah. If I am having 2 cross 3, I need to have 2 cross 3 matrix only, else addition and subtraction of matrices is not possible. So there is a compatibility reason for addition as well as multiplication. Like this, for multiplication also we have a certain condition. When can we multiply A and B? So now if I have to add A and B, they have to be of the same orders, and hence this A, second addition A plus B, is not possible. So now running to the third question, can we do that? I think they are of the same order, is it not? The question number 3, we have one matrix is this is 2 cross 3, this also is 2 cross 3, so I can do this 2a minus b. And I was telling you something about scalar multiplication. What do you mean by scalar in mathematics? It is a constant. We had discussed this during the definition of scalar matrix. So when I say scalar matrix, I will take certain number scalar and multiply to the entire matrix, all the elements of matrix A. So I have to do 2a minus b. How do I do 2a minus b? I multiply all the elements of matrix A by 2 and then subtract that from B, not from B. To B will be subtracted from 2a. So now let us do the problem. I will directly get into 2a minus b. I shall write one step extra. 2 into the matrix A is 1, 2, 3. When you are particularly doing this problem in the examination, this step is unnecessary. 2a minus b. B is 3 minus 1 3 minus 1 0 2. You have like this, and I'll multiply is equal to 2 4 6 4 6 2 minus 3 minus 1 3 minus 1 0 2. When it comes to subtraction, again it is subtraction of the corresponding elements, and many a times during the higher level problems, that is a 5 marker or 4 marker problems, if you have minus in between, it is always safer to take plus here and take off minus inside. Now I could have taken minus and multiplied with all these elements so that this becomes plus, and that will always be errorless. That's better. But anyway, now we are doing subtraction here. The corresponding elements, 2 minus 3 is minus 1, 4 minus of minus 1 is plus 5, 6 minus 3 is 3, 4 plus 1 is 5, 6 minus 0 is 6, 2 minus 2 is 0. I have got the matrix, and this also is of the order 2 rows and 3 columns, so it is of the order 2 cross 3. Now this is about the general addition and subtraction of the matrices, and now let us get into the properties of the matrices. Okay, here we go to the properties of matrix addition. Addition, and we don't discuss the properties under subtraction because we generally don't do that. The same thing will hold good, but then under addition it is very important. Properties of matrix addition, the commutative law. Now all these laws I have discussed during this chapter, relations and functions. Okay, under relations I have told you, I have explained you under groups, when it is called as a monoid, when it is called as a group, when it is called as abelian group, and so on. There we have discussed all kinds of properties, so you should be more familiar about these. So I'll go quickly. Properties of matrix addition, the very first one, commutative law. Now what do you mean by commutative law? A plus B is equal to B plus A, and I'm sure you know this, and I'll take A plus B and I shall take B plus A, 1 2 0 1 plus 0 1 minus 3 4, something like this. I have taken an example the way I want. This is 0 1, both are of the same order, so I can add them, but I'm doing A plus B and B plus A, 1 2 0 1. Now what is this? 1 plus 0 is 1, 2 plus 1 is 3, 0 minus 3 is minus 3, 1 plus 4 is 5. This is your LHS, is equal to 0 plus 1 is 1, 1 plus 2 is 3, minus 3 plus 0 is minus 3, 4 plus 1 is 5. So this is 1 3 minus 3 5. You see that LHS is equal to RHS. I just quickly took out an example that addition, whether you do 2 plus 3 or 3 plus 2, is the same thing in arithmetic with respect to numericals. The same thing holds good for matrix addition when it comes to the elements as numbers or complex numbers or whatever. So addition will be the same thing. And now let me go to the second property, that is associative law. Matrix addition is also associative. The way you add, see 2 plus, like for example I'll tell you, because it's corresponding elements, 2 plus 3 plus 5 will obviously equal to 2 plus 3 of plus 5, is it not? The way you add in LHS, first inside the brackets and then to this, or in the RHS, first inside the brackets and then to this, you get the same additive element. So let us see, 2 plus 3 plus 5 is 8 is equal to 5 plus 5. 2 plus 8 is 10 and 5 plus 5 also is 10. Now likewise this holds good for all the, suppose I take 3 cross 3 matrix, even if the two matrices are of 3 cross 3, every corresponding elements likewise I can add with A, B and also the third matrix C, because it is always of the corresponding. First you do A plus B and then with C, or first you keep A as it is, do B plus C and then add it to A, it's all one and the same. So I'll only write the property associative law or associative property. Associative law, it tells A plus of B plus C. First you add B and C, then you added that to A, or you first add A plus B and then add this added matrix to the third matrix C. Both will give you the same result. And now let me go to existence of additive identity. Now what is the identity element under numericals and numbers addition? We know that 0 is the additive element, additive identity under addition of numbers. Why? Because any number added with 0 gives you back the same number. Whether you take 1 plus 0, it will be 1, or you take 10,000 plus 0, it gives you back 10,000. That is why 0 is called as the identity element under addition of numbers. So I wanted you to remember, in the same way it holds good for matrices also. So what matrix I should add with any matrix A so that I get back the matrix A? that will be a 0 matrix. So any number added with 0 will always give you the same number, hence in matrix also the same kind of identity we write, and that is nothing but the null matrix. So let us write the law now under matrices: existence of additive identity. You know, we don't call this as identity law or identity property. You know, we don't tell that. We call only the name. It's told only as existence of additive identity. Exists or not? First of all, yes, it exists under addition. So which is that 0 matrix or null matrix or null matrix. It is represented by what? It is represented by O. Null matrix O is additive identity, or I'll say is identity element under addition operation. Is identity element under matrix addition. Under matrix addition. And how do you write it in the symbol? It's like this: A plus O is equal to O plus A will always give you back A. Now without identity element we cannot find out inverse. This also we have learnt in the relations and functions chapter. Now I have my identity element which is under addition, which is that 0 matrix. When I am having 0 matrix as the identity element, I am going to have surely my inverse. So let us see. Of course it is not sure. Existence of identity element doesn't mean that inverse always exists. Sometimes identity element will be there but the inverse does not exist. But the converse is very much true. Listen properly. If the inverse exists for every element, then identity element is for sure. Okay, let us see what is inverse. Now for this inverse also I had started with a simple example. Okay, so now let me go to existence of inverse. I shall tell you the same simple example what I had told in the previous class. Existence of additive inverse. Additive inverse. It's like this. I had told you like this. Take the number 2, and what if you add with this? You will get the identity element under addition. Now we know that identity element under addition is 0. So what if you add to any element, so that after addition it should end up giving the identity element, then that element is said to be the additive inverse of this, and vice versa. This will be the inverse of additive inverse of this element. So which element is that? Minus 2. So we say additive inverse of plus 2 is minus 2 and additive inverse of minus 2 is plus 2, because when you add this plus 2 and minus 2 you are getting 0. Likewise in matrix. Okay, so what matrix should you take with A so that you get 0 matrix? Because 0 matrix just now we saw that is the additive identity under addition of matrices. So in matrix chapter, if I take a matrix A, what should you add with this so that you end up getting 0? Of course all the elements with the opposite sign. When you write all the elements with the opposite sign, what you get is negative of this matrix, and that is called as minus A. Okay, so the way we deal with arithmetic numbers here in algebra with the matrices also, minus A is said to be the additive inverse of plus A, and plus A is said to be the additive inverse of minus A, because when we add the corresponding elements of these two matrices we end up getting the 0 matrix with matrix with all the elements equal to 0. So let us write it clearly. Existence of identity inverse, we say minus A is said to be the additive inverse of plus A. Why? Because A, that is plus A, plus when you add with minus A, or the minus A when you add with plus A, you always get the null matrix. So these two are said to be the additive inverses of each other. So this implies what? Minus A is additive inverse of plus A. So now I'll go for second order simple matrix, say 1, 2, 3, 4. Now what should you add with this? What is the inverse of this? A inverse, additive inverse of this will be equal to, let me not write A inverse, I'll write additive inverse of A. Additive inverse of A will be equal to, for 1 I should put -1, for 2 I should put -2, and for 3 I should put -3, and 4 I should put -4. In case if I had taken -2 here, I should have put +2 here, because when you add these two, A and this, let me call this as A1 and this as A2. When you add A1 and A2, you're ending up getting. So I'll write now A1 plus A2 will be equal to 0, 0, 0, 0, which is a null matrix O. Now because I'm getting O outside, we say A1 and A2 are additive inverses of each other. Additive inverses of each other. Okay, this is pretty simple, and now let us get into the problems under this. And children, under the properties, the associative law, the commutative law, the inverse, both in multiplication as well as addition, based on this you will get one 5 marker for a PU board examination, and that's for sure. So the properties verification, whenever you want to do verification, please take care that you will do LHS separately and RHS separately, and there will be a lot of calculations in this. You should be good in using your calculator also. So now we are going to a few examples under this. We have properties of scalar multiplication of a matrix. We were talking about scalar multiplication. So what do you mean by a scalar? Scalar is a constant number which will be multiplied to every element of a matrix, that is called as scalar matrix. Okay. So now suppose I have here you have under properties. Under properties, the first one tells you like this, that is K of A plus B will be equal to Ka plus Kb. Okay, add the matrix and then take this K, or individually you multiply this number to A as well as B and then add them, both mean the same thing. So whenever you have scalar multiplication, the matrix addition with the simpler elements is always easier. So whenever you find something common, please bring that outside, and whenever you want to take out something common also, you should see that all the elements in the matrix should have the same common multiple for it to be brought outside. So K into A plus B is equal to Ka plus Kb. The second property tells you that K plus L into A is equal to Ka plus La. What do you mean by this K and L? Where K comma L belong to real numbers. It may be any numbers, okay, or belong to integers, anything. These may be two numbers. One I have to multiply A with 2 also and 3 also. So basically you can and then add. So instead of that you can say 2 plus 3 5. Once for all you can multiply that 5 to A instead of doing it separately like this. So both this will be tedious here. Here this will be tedious, so we'll not do like this. If you have like this, we'll take out K common here and we'll take out L common here, add the elements and then multiply to A. That will be better. So these two are the properties under scalar multiplication, and of course the usage is just depends on the kinds of problems that we get. We go to the question number 1 here. I have find x and y. Now what are x and y here? X and y are not elements. Here x and y are matrices. See, you have capital X and capital Y here. Capital X, capital Y indicate what? The matrices, okay, the full matrix. If they are telling small x and small y, see in the next question, find the values of x and y. These are the elements inside the matrix. So when they are taking elements inside the matrix, do the equation, solve the equation the way it is given. It may be along with addition as well as multiplication also, sometimes only multiplication, sometimes only addition. So it depends on the kinds of questions they have given. So capital letters indicate what? The matrices. So now I am going to this x plus y, find x and y if x plus y and x minus y both are given to you. So I shall take x plus y, which is equal to 5 to 0, 9. Under that I will write x minus y, because this problem should be done the way you do your simultaneous equations in algebra. X minus y is 3, 6, 0, minus 1. You have x plus y and you have x minus y. So we do just like your simultaneous equations. See here, when I say plus y, when I add these two these two equations, plus y minus y gets cancelled, x plus x is 2 times the matrix x is equal to, add the corresponding elements because it is addition of matrices. Addition of matrices, 5 plus 3 gives you 8, 2 plus 6 gives you 8, and then 0 plus 0 is 0, 9 minus 1 is 8. Oh, and now what is x equal to? Then you have into here, transpose 2 to the other side, you have 1 by 2 into 8808 is equal to 4404. So you have x equal to 4404. And now this is the x matrix. I have to find out y also, is it not? What will you do in simultaneous linear equations to get the second element after getting first element, first variable? Here also do the same thing. I have got the x matrix here. I'll go to one of the simple equations, one of the equations whatever they have given, whichever I feel simple, plug your x matrix, you'll get your y matrix. So let me call this as equation number 1. So equation number 1 implies y is equal to this matrix, x transpose as I takes minus x form, so it will be 5 2 0 9 minus the x matrix, so I'll write x matrix here. Okay, so that will be 4 4 0 4. I'm subtracting, so y is equal to 5 minus 4 is 1, 2 minus 4 is minus 2, 0 minus 0 is 0, 9 minus 4 is 5. I've got my y matrix. So this is y matrix and this is your x matrix. I've solved the equation. So it is exactly like your simultaneous equations. And suppose they have given x plus 2y and 2x minus y something, then you do the elimination method. You have to multiply one of the equations in such a way that, or maybe two equations in such a way that the coefficients of x or y will become the same, and then you can subtract or addition, you can do addition as required. Now we go to the next question where you have to find out the values of the variables x and y which are the elements inside the matrix. Now here children, I would like to tell you like this, I don't want to do the entire problem, I have to end up very quickly. See, I have 2x here, when I multiply 2 this becomes 2x, and then I have the corresponding element is 3, so I'll add the corresponding elements plus 3, and then I have is equal to the corresponding element will be 7. Now this will be the easiest way of doing, instead of multiplying 2 to the entire matrix, fraction of seconds we can finish. So I shall take the question and do the way I told you, x5 7 y minus 3 plus 3 minus 4 1 2 is equal to 7 6 15 14, and there is always a possibility of making errors when you are copying the questions. So this is it's a fatal mistake, you should never do that. Whenever you have a problem in making silly mistakes, you should always be careful. So you write the question and come back and check whether the question what you have taken from the question paper is right or wrong. So we have 2x, I told you we'll take only the corresponding addition to do it very quickly. 2x plus 3 is equal to 7. So I have 2x is equal to 7 minus 3 is 4, x is equal to 2. Now I want y. Where is y? Take the corresponding elements. You have 2 into y minus 3, you should never forget. So it will be 2y minus 6 and the corresponding elements is this, and that is plus 2. Plus 2 is equal to, and the corresponding element is 14 is equal to 14. This will give you a quicker result. So this will be 2y, 2 minus 6 is minus 4, push that side is plus 4. So you got 2y is equal to 18 and y is equal to 9. So we ended up getting the answer, x is equal to 2 and y is equal to 9. So we did the second problem, and now we go to the third problem. The next kind of problem, see you have simple problems from this exercise 3.2. Question number 1 from exercise 3.2 will be A is equal to 2 4 3 2. I shall do like this. They are telling us in this question number 1 to find out a plus b, a minus b, 3a minus c. Let's do it in only 3 lines. I'll take a plus b instead of only a. So I go for the first problem and the first sub question in that, that is a plus b equal to, you have 2 4 3 2 plus 1 3 minus 2 5 equal to, that's 2. So 2 plus 1, 2 plus 1 is 3, 4 plus 3 is 7, 3 minus 2 is 1 and 2 plus 5 is 7. We are done. That's a plus b. And I know that this is going to be very simple for you. So be quick. A minus b, I shall go for a minus b directly here. 2 minus 1 is 1, 4 minus 3 is 1, 3 plus 2 will be 5, you got me? 3 minus of minus 2 will be plus 2, so 3 plus 2 is 5, 2 minus 5 is minus 3. So this was a plus b, and this is a minus b. I have subtracted these two matrices. So I'll check once again. 2 minus 1 is 1, 4 minus 3 is 1, 3 plus 2 is 5 and 2 minus 5 is minus. This is a minus b. Next I want 3a minus c. Third, I am doing 3a minus c. So I shall take 3 times a first. I will go to a matrix. This is my a matrix. I shall multiply a matrix all the elements by the number 3. So there will be 3 2s are 6, 3 4s are 12, 3 3s are 9, 3 2s are 6. Minus c element. Your c element is, c matrix is minus 2 5, minus 2 5 3 4. Okay, once for all we'll subtract. So I have subtraction here is equal to 6 minus of minus 6 plus 2 is 8, 12 minus 5 is 7, 9 minus 3 is 6 and 6 minus 4 is 2. Okay, this was the simplest multiplication that you could do. And now when we come to these second question, it is very interesting. And we can finish up now. These I have taken very few examples, few problems from your exercise. Now what are all the problems that I have done? Please sit and complete all the other problems from your exercises. Anything you can always reverse back. See, compute the following here. Compute is do whatever is necessary here. It is addition over here, and I have to multiply. I have to add the two matrices. Of course, we add the corresponding elements. So you have a square plus b square plus 2ab. What does that give you? So I am doing directly. I shall not write the question. The second question. This is a second sub question, of course, from the textbook. The first sub question I have left it as homework for you. You have a square plus b square plus 2ab. You want me to write? I don't want to write, but still I'll write because I'm not writing the matrix also. Plus 2ab, I have added already. Next I'll take, you have b square plus c square plus 2bc. That is the second a12 and a12 I have added. Next I'll take a21 and a21 here. See, a21 plus b21 now we can say. So a square plus a square plus c square minus 2ac, and the other two elements are a square plus b square minus 2ab. Okay, now what do you see in this actually? They're all the algebraic a plus r minus b square formulae. This is a square plus b square plus 2ab, which is nothing but a plus b whole square. A plus b the whole square. This is b plus c the whole square, and this is a minus c the whole square, and this is a minus b the whole square. Okay, so I've got my matrix. So every element is the square. Okay, and even by chance you cannot think that the entire matrix can be written as whole square. No, it's impossible. Every element has been the square of two elements, or the subtraction of two elements, the square of the subtraction of two elements, according to algebraic formulae. Now I am going to the fourth sub question. Similarly, third sub question I have left it for your homework. This is damn simple. Cos square x plus sin square x is always equal to 1. So we will be using cos square theta plus sin square theta, trigonometric identity is equal to 1. When I use that, I get, so it is like this. You have cos square x plus sin square x. Then you have sin square x plus cos square x, once again the same thing. Then you have sin square x plus cos square x. Then you have the cos square x plus sin square x. Each one is equal to 1. So this became a matrix with full of ones. 1 1 1 1 is our element. Okay, yeah, is our matrix. The matrix is full of ones. where we use. And one more thing, suppose they are given cos square x and sin square y here, it doesn't become 1. Cos square of some theta plus sin square of the same theta will always be equal to 1. So cos square x plus sin square y is not 1. If they say cos square x and sin square y, you will write it as cos square x plus sin square y only. It will not be equal to 1. Okay, and now we let us shift to the next kinds of problems or the theory whatever we have here. We have the next problems like this. A, B, C are given and you have to compute A plus B, B minus C, and then you have to verify. Look here children, this is the verification kind of problems what I told you, which will be occurring for 5 marks in PU board examination. Maybe for the entire mathematics this is going to be the simplest one that you can do by yourself even without teacher's help. See, that is A plus of B minus C. Do LHS and RHS the way it is bracketed. And now I will directly get into A plus B and B minus C, and then I do that verification. So I shall do A plus B. A plus B is equal to 1, 2 minus 3, 5, 0, 2, 1 minus 1, 1 plus you have B as 3 minus 1, 2, 4, 2, 5 and 2, 0, 3. I shall add this. We want A plus B, right? A plus B. So 1 plus 1 plus 3 is 4 and 2 minus 1 is 1, minus 3 plus 2 is minus 1, 5 plus 4 is 9, 0 plus 2 is 2 and 2 plus 5 is 7. This is minus 1. Then 1 plus 2 is 3, minus 1 plus 0 is minus 1, 1 plus 3 is 4. Okay, this is A plus B. Next I shall take B minus C. B minus C. B I'll take, I have B here. 3 minus 1, 2, 4, 2, 5, 2, 0, 3. Minus C. What is your C matrix? 4, 1, 2, 0, 3, 2. 4, 1, 2, 0, 3, 2. And 1 minus 2, 3. 1 minus 2, 3 is equal to, okay, I am subtracting B minus C. 3 minus 4 is minus 1, minus 1 is minus 2, then 2 minus 2 is 0, 4 minus 0 is 4, 2 minus 3 is minus 1, 5 minus 2 is 3, 2 minus 1 is 1, 0 plus 2 is 2 and 3 minus 3 is 0. Okay, I have got my A plus B and B minus C. As they have told, I am doing the steps the way they have asked. A plus B and B minus C are over. Now I have to verify that A plus B of B minus C is equal to A plus B of minus C. First we should do whatever is bracketed. So now I shall take that also as the linear equation. A plus B minus C should be equal to A plus B minus C. Either you can write once for all and do and see that LHS is equal to RHS, or you can do it separately, LHS separately, RHS separately, and then declare yes they are equal. I shall take it as an equation in this simpler problem because I can do at a stretch. You have A, I have A here, so I shall take 1, 2 minus 3, 5, 0, 2, 1 minus 1, 1. And I have my B minus C ready. B minus C is this. Minus 1, minus 2, 0, 4, minus 1, 3, 1, 2, 0 is equal to A plus B. A plus B I have here 4, 1, minus 1, 9, 2, 7, 3, minus 1, 4. Minus the matrix C, which is C. C is this. So it is 4, 1, 2, 0, 3, 2, 1, minus 2, 3. So I have put all the corresponding matrices. And as you know, see, this is the simplest one, is it not? It is simple direct addition subtraction. So 1 minus 1 is 0, 2 minus 2 is 0, minus 3 plus 0 is minus 3, and then 5 plus 4 is 9, 0 minus 1 is minus 1, 2 plus 3 is 5, 1 plus 1 is 2, 2 minus 1 is 1, 1 plus 0 is 1. Okay, next you have 4 minus 4, 4 minus 4. I have to do addition here and I have to do subtraction here, children. So you need to be careful. 4 minus 4 is 0, 1 minus 1 is 0, -1 minus 2 is -3, 9 minus 0 is 9, 2 minus 3 is -1, 7 minus 2 is 5, 3 minus 1 is 2, -1 plus 2 is -1 plus 2 is 1, 4 minus 3 is 1. Have you got the same thing? Let's compare 0, 0 minus 3, 9 minus 1, 5, 2, 1, 1 and 2, 1, 1. Okay, we have got LHS is equal to RHS. So we say LHS is equal to RHS, hence we have verified. Hence verified. And of course, when I tell you that these kind of questions will compulsorily come for PU board, it won't be this simple also where you have only addition and subtraction. It will be associative property with multiplication of matrices, which will be quite tedious to do, or it may be some equation where you have a cube minus 2i plus 3r plus 3 something is equal to 0. You have to prove like this. So it will be only on addition, multiplication and subtraction of matrices. Be thorough in this. A little mistake somewhere here, you lose your time in examination hall, and you should be perfect with your addition, subtraction and multiplication. So now we go to the next question here. Again in the next question, see, you can see find x and y if x plus y and x minus y, 2x plus, we already did this kind of problem, x plus y. So I shall do it in one line, x plus y and x minus y. The next one we'll do in detail. Now we go to question number 7 in your textbook, and all the in between problems, children, it is your responsibility. It's quite a simple chapter. Please have a notes, maintain a notes for yourself. It's always important, where you have the entire textbook with questions and answers, and also the theory what we explain. Okay, now I have find x and y if x plus y and x minus y are given. What I do here is I shall take x plus y, I'll add, okay, I shall call this as equation number 1 and this as equation number 2, and I see directly that I have plus y and minus y. So if I add these two statements, plus y and minus y will get cancelled. So I shall do equation number 1 plus equation number 2 for 7th first sub question. When I say 1 plus 2, you get x plus y plus x minus y is equal to, I am adding the two matrices, 7 plus 3 is 10, 0 plus 0 is 0, 2 plus 0 is 2 and 5 plus 3 is 8. We have got like this, and here plus y and minus y gets cancelled. You have 2x is equal to 10, 0, 2, 8. And this in turn implies I got my x matrix as 2 5s are just divided, 2 you transpose to the other side, you get becomes 1 by 2. So you will get x matrix by dividing every element of this matrix by 2. So I'll multiply, I'll divide, 10 by 2 is 5, 0 by 2 is 0, then you have 2 by 2 is 1 and this is 4. 5, 0, 1, 4. These are x matrix. Now to find out y, I'll go plug it in one of the equations. I'll go to equation number 1. I shall plug in 7, 0. Equation number 1 implies 7, 0, 2, 5. And you have plus y is equal to, my x matrix, I think I went wrong, is it not? This is wrong. I have x here. So I shall replace my x matrix, that is 5, 0, 1, 4 plus y is equal to, in the question they have given this as equal to 7, 0, 2, 5. So you get y is equal to, this matrix when you push the other side it takes the minus form, so I'll subtract. 7 minus 5 is 2, 0 minus 0 is 0, 2 minus 1 is 1, 5 minus 4 is 1. Okay, this is my y matrix. Now this I have done, like this kind of problems we have done 2 already. Now we are going to the next question where you don't have any elements, wherein I can directly add or subtract and take this plus y and minus y or plus x and minus x. So the next one again we are going to do just like the simultaneous linear equations. So we go to second sub question 7. Second sub question, I'll write like this, 2x plus 3y is equal to 2, 3, 4, 0. Underneath this I'll take the second equation, that is 3x plus 2y. 3x plus 2y is equal to 2 minus 2, 2 minus 2 minus 1 5. And now I have to either make the coefficients of x same or the coefficients of y same. I shall multiply this entire equation by, I shall take the coefficients of y to be same, so I will multiply this by 2 and I shall multiply this entire equation by 3. So this implies what? 2 I will multiply to this and this part. 2 2s are 4x, then 2 3s are 6y is equal to 2 multiplied to the all the elements. This 2 should be multiplied to all the elements here. You end up getting 4 6 8 0. This is 4x plus 6y. Likewise, I'll multiply 3 to the entire of this equation. You will be getting 3 3s are 9x plus 3 2s are 6y is equal to 3 2s are 6 minus 3 and this is 15. Now I'll subtract this because I have plus 6y and plus 6y. So we are subtracting the two equations, which means that I need to change the signs here. Plus 6y minus 6y got cancelled. 4 minus 9 is minus 5x is equal to 4 minus 6 minus 2, and then is this 6 or minus 6? Oh, it is 6. So see, you have to read the elements properly, you should never go wrong. 6, and I am subtracting. 4 minus 6 is minus 2, 6 plus 6 is 12, 8 minus of minus 3, 8 plus 3 is 11, 0 minus 15 is minus 15. I will check once again, children. You should not take a break in between or talk something else, then the focus will go. I have to check here once again. 4 minus 9 is minus 5. I am subtracting. 4 minus 6 is minus 2. 6 plus 6 is 12. 8 plus 3 is 11. 0 minus 15 is minus 15. Okay, we have done correctly. So now x is equal to minus 1 by 5 of this, which means I have to multiply every element by minus 5. So I will multiply x is equal to, it is 2 by 5 and then minus 12 by 5, minus 11 by 5, and minus will get cancelled. 15 by 5 is 3. I got my x matrix. Okay, after getting my x matrix, next I shall do for y, I shall plug this in one of the simple equations which I have. I shall take the first equation and let me call this as my equation number 1. So equation number 1 implies 2 times x. What is your x matrix? I have got here 2 by 5, minus 12 by 5, minus 11 by 5 and 3. Okay, 2 times x plus 3 times y is equal to the matrix 2 3 4 0. I have got like this. Okay, so 3y is equal to 2 3 4 0 minus 2 times this entire matrix pushed off to the other side, it will become minus. So I shall multiply by 2 and I have taken the subtraction also. So when you say multiply, this will be 4 by 5, this will be minus 12 2s are 24 by 5, this will be minus 22 by 5 and 2 3s are 6. Okay, so now y is equal to 1 by 3 of 3 also pushed off the other side of the subtraction of these two matrices. So let us do 2 minus 4 by 5. 5 2s are 10. 10 minus 4 is 6 by 5 I got. Next, 3 minus of minus 24 by 5. So it will become plus, and then 3 minus of minus 24 by 5. I shall do some rough job here. It is like this. 3 minus of minus is plus 24 by 5. 3 5s are 15 plus 24 divided by 5 gives you 39 by 5. Okay, next 4 minus of minus. So this is going to be 4 plus 22 by 5. So 5 4s are 20 plus 22 will be 42 by 5. Or next, 0 minus 6 is minus 6. And I had to divide by 3. When I divide by 3, 3 1s are 3 2s are will go here. So 2 by 5. And then 3 1s are 3 3s are will go. So you get 13 by 5. And then here, this is 14 3s are 42. So 14 by 5 and this is minus 2 I have divided. So this is my y matrix and where is my x matrix? Therefore x is equal to this is my x matrix. We have found out x and y. And in generally they don't give such equations because such questions cannot be given for 5 marker and the 2 marker or the 3 marker whatever they give it will be with simple equations only. But whatever given the point is it is simple algebra. You should have to be very perfect in calculations, addition, subtraction and copying of questions properly. And once you start a numerical question like this, until and unless you finish the answer, you get the final answer, please don't take any pause in between either to talk to your friend or go to the back pages or see here and there or drink water, whatever. So once you start the problem with the calculations, you will have a flow, that speed will be there and the accuracy will be there. So we'll see what we have for the next questions. We have question number 10, 11, 12. So we go there where we need to find out the value of x and y. These are the very frequent questions that occur in objective type of questions, maybe for competitive examination or maybe only for 1 or 2 marks of your problem of your question paper. Solve the first equation. See, you have solved the equation for x, y, z and t they have given, and I want you to follow a certain idea where you can cut short the procedure. You need not multiply everything. I shall write the entire equation, entire question. 2 into x, z, y, t you have, and then you have plus 3 into 1 minus 1 0 2 is equal to 3 into once again 3 5 4 6 3 5 4 6. I don't want you to multiply 3 inside this 3 inside, push off this matrix to the other side, subtraction. No, I don't want to do that. I wanted to find out all these 4 variable values only by simple equations. So we'll divide the page into 4 parts and we'll find out x, y, z, t. I'll go for the x part. X is in the A11 place. Multiply x here. That's what is the given 2x. Then you add plus 3 into again the first. So it will be plus 3. Then you have equals. So is equal to. The corresponding elements is 3 into 3, that is 9. See, we got x value. So 2x is equal to 9 minus 3 6. I got x is equal to 3. Bus, you have to do only so much. So let's continue like in the same fashion to find out y, z and t. I'll go to y. 2y. So you have 2y plus 3 into 0 is 0. Even by chance you should not be writing it as 3. 3 into 0 is 0 is equal to 3 4s are 12. So y is equal to 6. 12 by 2. We got y 6. Next I'll go for z. Z is in A12 place. So I have 2 into z. 2z plus 3 into minus 1 is minus 3, which is equal to 3 5s are 15. So you got 2z is equal to 18. So z is equal to 9. And then the corresponding, the last element, 2 into t is 2t plus 3 into 2 is 6 is equal to 3 6 are 18. So 2t is equal to 18 minus 6. 18 minus 6 is 12. So 12 and you got t is equal to 6. So I found out all x, y, z values. Now this is the way I want you to do when it comes to finding out the variable equations, finding out the value of the variables equations. Now we go to question number 11. Okay, here too I'll write the equation, but here I think there is no other go, you need to multiply and make equations. X into the column matrix 2 3 plus y into the column matrix minus 1 1 is equal to the column matrix 10 5. So here I want the values of x and y and you don't have the corresponding elements. See, I have 2x here, 2x, and then when I multiply this with this element will be 3x only. So I can't go, I'll go further. 2x minus y is equal to 10. I got one equation. Next I'll take 3x plus y is equal to 5. So these two equations solve simultaneously to get x and y value. We see minus y plus y gets cancelled. 2 plus 3 is 5x is equal to 15 and this fetching you x is equal to 3. Simple. We got x is equal to 3. Plug in x is equal to 3 in equation number 1 I shall call equation number 1 here. Equation number 1 implies 2 3s are 6 minus y is equal to 10. So y is equal to 6 minus 10 is minus 4. And generally whenever you have simultaneous equations, you better always go for verification to be sure for your marks. See, x is equal to 3 and y is equal to minus 4. X is equal to 3, 2 3s are 6, minus of minus 4 is plus 4, which is giving you 10. This is always the best method. Okay, and then the last one is rather more easier than these two. I think corresponding equation should be giving you the values. Do we get, or do we get simultaneous equation? Let's check out. 3x is equal to x plus 4. Oh, that's easy. Okay, I'll do directly from there. Equations, that's question number 12. I shall go with the first equation. 3x, the corresponding elements of a11 place. 3 into x is equal to x is equal to x, and then you have plus 4 plus 4. 3x minus x is 2x is equal to 4, so you got x is equal to 2. Okay, next I'll go for y. Y is 3y. 3 into y, I multiplied 3 into y, the corresponding elements is equal to 6 plus x plus y wherein x is equal to, this is equal to 2. So I got 3y minus y is 2y is equal to 6 plus 2 is 8, y is equal to 4. Okay, next I have to find out my z. Z is equal to, z the corresponding, oh 3z, it's not only z. Oh, that was a blunder. 3z is equal to, 3z is equal to minus 1 plus z plus w plus z plus w. So 3z minus z is 2z is equal to minus 1 plus w. I neither know z nor know w. Let's catch up with the other equations. The next equation, I shall take the next corresponding elements, that is with respect to a14, sorry a22, correct, right? Second row, second column, a22, 3w. 3w is equal to 2w is equal to 2w, and that is the next power will be plus 3. 3w minus 2w is 1w is equal to 3. I got w is equal to 3, so I shall plug w is equal to 3 here. I got 2z is equal to minus 1 plus 3 is equal to 2, so I got z is equal to 1. So I got z is equal to 1, and then x is equal to 2, y is equal to 4, and w is equal to 3. We have got all the values, and this is how we are going to find out the values of unknown things, unknown elements inside a matrix, which is depending only on addition as of now and the scalar multiplication. So with this we have finished the exercise 3.2, which was based on addition, as I told you. Next we will be getting into multiplication of matrices, properties of multiplication of matrices. When is multiplication possible? That itself is a very important aspect in matrices. And what is the speciality of matrix multiplication? One more important point is there. And multiplication is the one where you have to be very careful, and all the problems in the board examination generally will be based, higher levels will always be based on matrix multiplication. So in the next class we will get into the matrix multiplication.